Hello everyone, so today we are going to do some additional queries and I guess this lab could fit into 1 hour, so we are going to try to do that. So again we are given an ODB database file, so if you would like to follow along you can download it, and this time it follows a different ER diagram. So whenever you open some other database that you didn't implement it, for example, to check the tables, we have tables option, but to see it in a better view, if you go through tools and relationships, then you will be able to see how these tables are related, and for each of these tables you actually see some summary view with all of the attributes, and you also see these key symbols next to the primary keys. So if you would like to maybe remember your own database, or if you are going to work on some other database, it is better to first go into this relationships view to check what is what in this database. So this is kind of simple, but we have tiny differences. So let's check what is happening in this database. We store students. So if you would like to look at the student table, we store them with their IDs, names, surnames. We store the age and payment. And additionally, we store a group number. So in the original ER diagram, you might have something like this. We can have a relationship between the students and groups, right? And let me also show the S group table. It is the groups for the students. We store the primary key group number and the group name. And we also store some group leaders ID. And these two are actually foreign keys that are inside our entities. So this is some entity for students, but I store a foreign key that references the group table. And in the group table as well, I store some foreign key that references the student table. Normally what we do is we create a separate table for the relationship in between, and we make our foreign keys inside this relationship to reference both entities. But in some cases, to reduce the number of tables, we can combine different tables together. And in here, that's what we have done. So instead of having a separate relationship to match one student with one group, because in the description, so there is no description, this is some database that we made up, but in such description that says that, okay, for every student there is going to be just one group, exactly one group, and there is no student without a group. In this case, if I were to have a separate table, in that table I will match the IDs of the students with their group numbers. And instead of doing it in a separate table, we just included the group number into the student table in this case, because every student is going to it is going to participate in just one group. And a similar case for S group. For every group, there is going to be just one leader, exactly one leader. And instead of keeping this in a separate table, because for one group we are going to match one student only, we just included it into the group information as a foreign key. So this does not work if we had a many-to-many case. So we are not allowing a student to go into multiple groups. In a group there can be still more than one students. This is a one-to-many case. So students, if I know the student, I should know the exact group. Therefore, we made it in such a way. So for the workscene and project, this is actually more easier. We store a bunch of projects with their descriptions and budgets. The project number is unique, but description is not. For example, we can have two different education projects with different budgets. Their project numbers are different. And in a workscene table, we match groups with project numbers. So students are in groups and they are working on projects through their groups. Basically, this is a many-to-many relationship. And if you wonder how we made these links, so these two could be more complicated, let me just get rid of all of these links, because soon for the implementation stage you are going to create your databases. Maybe this is going to be a good way to remember how to do that. So remember, we can drag and drop attributes into each other in different tables to create links among them. And while we are doing that, for each link we are actually defining a parent table and a child table. And in the parent table, so for example for project and works in, the parent table is going to be project for project numbers. And this means that in order to create some project number in the child table, that project number should exist first in the parent. So I'm going to drag starting from the parent, which is the project, into the works in, and I'm using the matching attribute names. The names does not have to match, but to make it easier to find out which are going to match, we gave them the same name. The parent should appear on the right side, and I'm just going to enable the update and delete cascade options. This helps us when we delete a project, the related entries in the child tables will be also deleted or updated, for example. This makes it easier to maintain the database. And for the group and works in, the group is going to be the parent with the group number. I drag it into the group now of the works in table, and I will enable delete and update cascade options. Now, so for the other ones, we were saying that, okay, from parent to child. So this is basically from entity to relationship, or in the case of aggregate relationships, from the relation that's inside the dashed rectangle into the aggregate one. Or in the ISA case, we don't have a separate relationship in between, we just drag from the parent into the child. But in this case, these two are entities. And let's start with the student part. So for the group number, let's say, I would like to assign some students into groups. This time these are entities, these are both entities, but one side is going to act like an entity in this relationship. One side is going to act more like a relationship. And that side is going to be for the group that this student is going into. For me to be able to enter some group number into the student table, that group number should actually exist first in the S group table. So therefore, the parent is going to be S group. So I will drag starting from the group number of S group into the group now of the student. So if I double click on it, I can enable update and delete cascade options as well. And for the other side, if I want to assign some student as the group leader, that student should exist first. So this time the parent is going to be the student side. So I will drag starting from the ID of the student into the group leader. This time the names are not matching. So the names does not have to match actually. We are giving the names, and like to make them more manageable, we were trying to have similar names. So this time starting from the ID of the student into the group leader attribute of the S group table. This says that there is already an existing relationship between these two tables. So am I trying to create a new one, or do I want to edit the existing one? In this case, we would like to create a new one. So I will choose create. And if I enable update and delete cascade options as well, this is how I create this link. So this is the same relationship setup. I will just save it. And when you are creating new entries, or when you are populating your tables, for example, if I were to start from scratch if I would like to create some new student, for example, 29, with some age, and if I was creating this database from scratch, meaning that if I didn't have any groups now, while I'm creating the students first, I will leave their group numbers empty. Because, for example, if I would like to assign them to some group with ID 10, I cannot do so yet because there is no parents, meaning that there is no such group with ID 10. I will leave this group number empty first, then create the group with number 10, for example, some group, and maybe that leader is not added into the database yet. I'm keeping the leader empty as well. Then I will go back into my student table, and then I can assign the student into group number 10 because the number 10 group is ready now. For example, let me add more groups with some group numbers. I can assign it to 10 with some payments, and this time if Ayşe is going to be the leader of this group, now I can assign Ayşe as the group leader. So okay, the problem now is that I see the pencil icon next to Ayşe. Ayşe is not added into the database yet. Therefore, it cannot find the student with ID 30. So I need to go out of this row to lose the pencil icon so that I know that this is added into my database. And in here as well, if I now go into some other row, it will be added into the database. So for this database setup, we are given a bunch of queries, and we are going to implement those queries. So I will go through queries and then create query in SQL view. So we are going to use SQL. We can also use the design view, but for some queries, the design view is not that easy to use. So for some queries, using direct SQL helps better. And also, when we start implementing some user interfaces, it will be better to use the queries, the SQL queries. So the first one says that list name, surname, and group name of all students, ordered by the group name and then by student name within each group. So we would like to actually, let's start with the things that we would like to project. We would like to project the S name. So this is the names of the students. Attribute name is S name. And the surname and the group name. And remember, we were using double quotations for each of our attribute names and also for table names. And these should match exactly. So if the S is uppercase, it should be uppercase. If it's lowercase in the table, let me show it, it should be, so in the student table, attribute names are all lowercase, for example. These should match exactly, otherwise we have an error. So this is going to be, so I would like to list the name and surname of the students, but I also want to show the group names. If I check the student table, in the student table I know the group number, but I don't know the group name. To get the group name, I should go into the S group table. So this means that I need to join the student table with the S group table. So I need the student table and the S group table. And remember, whenever we include more than one table, if we would like to join them, we need to specify the join conditions. So the join condition, if you don't remember the join condition, you can check the relationship table. Between student and S group, we have two different options to make the join operation, but this time we are interested in the groups this student is going into. So we are not looking at the leaders of the groups, we are looking at the student and the group that the student is in. So therefore I need to join through group no in both tables. So I will say from the student table I have an attribute called group no, group underscore no, and this should match with the one that's inside S group. And these dots mean that this attribute is coming from this table. And if the attribute names are different, I don't need to include the table names, but in this case, in both tables, they are called the same thing. Therefore, to refer to the individual ones, I need to specify the table name. This is actually our join condition. And the additional thing is that we want them ordered by some attributes. So we have the keyword order by for that. So we would like to first order them according to the group name, and then according to the S name within each group. So in this case, we are not using any group by operation. Actually, we are talking about the groups of the students when we say that within each group. So let's run it, and these are the results. So for each of the students, they are in some group, and these two are the ones that we just created. So let's save this query as query number 1. I'm going to close it and create a new query for the next one. Create query in Escrow. So the next one says that list name and age of student doubles who have 5 years of difference in their age. So we would like to select the S name and the age for some students, so from the student table. But in this case, it says that student doubles, so I need 2 different instances of this student table. So I would like to set one of them to one student, and the other student is going to have a 5 years of difference in the age. So with just one instance of this student table, I cannot do that. I need 2 different instances, and to be able to refer them separately, we give names to these instances. So for this table, I bring some new instance, and that will be called S1, and for this table I will get a different instance, and this time it will be called S2. Since I include 2 different tables, now each of them has S name and age. By default, if I don't specify the table names, it will be using the first instance of S name it encounters. So in the from lists, from S1 we encounter first the S name and then age, and in S2 there is also S name and age. But if I don't specify which table this is coming from, in LibreOffice it uses the initial one. But in some other application it might give an error. In Access, for example, it was given an error. So it is better to always specify when you have the attributes with the same name in multiple tables. So actually in this case we would like to show both sides. So we are talking about student tables. I'm showing the S1 size name and age, and I would like to also show the name and age from S2 side. So if I just run it as it is now, I will see that it is making the Cartesian product between the same student table but different instances. So each of these students are matched with each of the other students, and they have their respective ages. And now I would like to have some condition to say that, okay, these 2 sides, let's look at the ages, and let's only include the ones that have a 5 years of difference in their age. So this is going to be a var condition. And in this case, we want one of the sides, for example, S1 side age, let's say it is going to be equal to S2's age plus 5, or I can write minus 5, then the left side will be bigger, etc. So this time the left side is bigger. If I include the minus sign, it will choose the right side to be larger in age. So both of them are okay. So if I run it now, only the students with a 5 years of age difference are listed, and we don't see the same names because we are saying that the left side is going to be the bigger one. So for example, Hal and Daisy is only appearing once. We don't see any Daisy and Hal because the left side should be the bigger one because we included the +5 on the right side. This is also done. Let's save it as query number 2 and let's create a new query. This time we would like to list all group names as well as the average payment of each group. So if I were to just list the group names, I have the Escrow table, but I'm also interested in some information about the groups of students. So within each group there are students, and I would like to find out the average payment of those students in some group. So in this case, we would like to select the group name and also some function. So I would like to find the average of the payment from the student table using some function. So remember this usage of functions. If I were to write find the average payment from the student table, it will calculate the average payment from the student table. But if I'm also projecting some attribute, for example, group ID, or it's called group no, sorry. So if I didn't include the function, for example, if I select the group numbers from the student table, it will display the group numbers. But if I try to show them at once, this is going to cause a problem because average payment returns just one value, but group number, projecting the group number of the student table, it is multiple things. So therefore it causes an error. So in this case, actually, this is not the thing that we are interested in, but just for some information. In this case, we need to use the group by because we are inspecting the groups of students. And if we group the students according to the group number from the student table, I can group them according to the group number. The group information is in that table, and I can show the group number as well as the average payment per student. So if I run this query, I will see the group number, the ID, followed by the average payment of the students that are in that group. So this number 10 is the new group that we just created. But this is not enough. It also wants the group names, right? So we need to somehow join it with the S group table as well. So this is going to be our S group table, and since I said that we need to join, we need the join condition with the var statements. So in the student table, this is the join operation that we just did. The group number should match with the group number in S group. So this is my join condition, and I can run it again, but nothing is changing because I did not include any additional select options. I would like to also show the group name. Remember, when I'm using the group by operation, the things that I project should be a subset of the things that I group by, plus the functions. So functions are different. I am not grouping according to any function, but I can use the functions. I can project the results of the functions when I'm using group by operation. But I cannot just directly go and say here, I would like to show the group name. It will cause an error. It will say that this is not a part, it is not in aggregate function or group. So this is the things that I'm grouping according to, but it is not among this group. So in this case, we also need to group according to the group name. So usually group name is not unique, so it's not the primary key. It can be seen as some unique thing, but in the database it's not the primary key, then there is no guarantee that it will be unique. But if I group according to the group number first, then for some groups with the same name, I guarantee that they will be separate. And this group name is not helping me for grouping the different groups, but it is included just for the sake of projecting the value. So now if I run it, I see the group names and the average payment of the students that are in that group. So let's save it as well. And for example, in this average column, I can assign different names for these columns as well. I can say average payment, for example, for the column name. If I run it, the column name is now replaced. So let's go into the fourth one. It says that list name and payment of students that are in the group which has the highest sum of payments. So we actually need to find multiple things in this case. We need to find the group with the highest sum of payments. So let's first start with finding the payments of groups. So in this case, I can say select the sum of payments. So this payment information and the group information is included in the student table, therefore it's going to be from the student table. So if I use just this, it is going to sum up all the existing students. But I'm interested in different groups, so I need to group the students according to some group number. So now if I run it, for each of these individual groups, I see the sum of payments. To be able to refer it in some other parts, I can give some name to this attribute. So for example, if I call it as the pay sum, payment sum, then this can become my subquery. And just let's leave it aside for now. If I were to find the group with the maximum payments, so I'm just going to cut it for now to make things simpler. Let's say that among this sum, I would like to, or let's maybe also first find the maximum sum as well. So from here, let's say that I would like to find the maximum value. So this is some result set, right? And I can say, okay, select the maximum of the thing that I call pay sum, because I'm calculating the sum of payments within each group. And now the column name is called pay sum. And I would like to find the maximum of this pay sum. So therefore I will say that select maximum pay sum, and it is going to be from this result set. So normally after from, what we write is a table name, but in this case, instead of writing a table name, what we write is some subquery that will return multiple results. So among these multiple results, we are going to get the maximum one. So if I run it now, it is going to get the maximum of these result sets. So without the from part, it was listing the payment per group. If I include the maximum one, it will just choose the maximum one. And maximum is 480. Let me just cut it out, so I will use this in a minute. But let's say that I know that one group is paid 480, and I would like to get the group ID or group number of this group. So in this new query, let's say, I would like to get the group number. So these informations with the payments are inside the student table. And since I'm looking at the groups, I will say group by group now. So I'm interested in the student groups, therefore I need to group the students accordingly. And for the groups, so remember, if I want to put some condition for the individuals, I can use where statements. But if I'm talking about groups, then I have the having keyword. And using heading, we are actually inspecting some value per group, and therefore I cannot write the attributes directly. So I cannot say having payments equal to some value, because this is for the group. In a group there are multiple payments. What I can do is use some function to compare. I can say, okay, the sum of payments of the group that I'm looking for is going to be 480. So if I run this query, it will display the group number of the group that has the payment sum as 480. And this is some valid query. And remember how we found 480. It was with this subquery. So now I'm going to use this query as my subquery in here. And I will say that, okay, this subquery I included in these parentheses. Let's try to make it look better. So this subquery is actually finding the maximum. And I can say that this will return just one value because I'm using the function. And for this value, let's get the group with the sum of payments that is equal to the maximum one. So if I run it now, it will again display the same group number because the payments are the same. And in the question it was also saying that list name and payment of the students that are in this group. So this is actually helping us to find some group. So let me actually keep it like this, otherwise we will run out of space. So now I find some group number from here, but I'm projecting the attributes. I can have more than one group with the same highest sum. For example, I can have some other group, and that group could have the same amount of sum of payments. In this case, this can return more than one things. So this part is going to be my subquery now. And given some group IDs, I can easily project the name of the students that are in that group. So I can say select S name and the payments from the student table. And for the students that I would like to show, there is one condition. And that condition is for these students' group numbers to be in this result set. So this part is actually returning me some values. Right now it is just one value. I can use the equal sign, but it's not the result of a function. Therefore there is the risk of multiple results returning. If there is the possibility that multiple results will return from a subquery, what we use is the keyword in. So whether it returns more than one thing or just one thing, it is going to act the same. It will make the group numbers to belong to the ones that are returned from here. So now if I run it, I will see these 4 students and their payments sum up to 480. And if we were to check, these students will be from group number 5. Let's check it quickly. So from the group number 5, I see these 4 students. Again, this is done as well. Let's save it and let me create a new query for the 5th one. List name, age and payment of students who are paid more than their group leaders. In this case, we need to get a member and a leader. And these 2 information are in the student table. Actually, maybe it's better to explain it in the relationships part. So let's say I have a student and this is going to act like a member. For this member, I need to find the group this member is in. And within that group, I would like to check the leader of that group. So the member and the leader is not going to be the same person. So these are going to be different persons. Therefore, I need 2 different instances of the student table. One will act like the member and the other one will act like the leader. So going back to the query now, we would like to select the S name and age and the payments of some students from the student table. But remember, we need two different instances of the student table. Let's call one as the member, and for the other one, let's call it as the leader. And to join them, I need the S group table as well, because without the S group table, I don't know which student is the leader of which group. So I will include the S group as well, but just once. Therefore, I don't need to assign a separate name for this other table. And since we include two different student instances, when we are projecting things, we need to specify which table it is coming from, and in this case I would like to show them from both sides. So I want to show the member, and I also want to show the leader with their name, age and payment information. So the only part left is going to be making the join operations, and we also have some conditions saying that the member should be paid more than the group leader. So to make the join operations from the student table that is called member, we actually need to follow the attributes that I just mentioned. So this is going to be the member. I join member through the group number, and then I join S group through the group leader and ID of the student. So I will just make those join operations. From the member table, I have the group no, and this should match with the S group dot group no, and at the same time, so we are combining them with and, otherwise it doesn't make sense. And within the S group, I have the leader information. It is called group leader. Actually, since group leader is only appearing in this table, the attribute name, I can omit the table name. I want this to be equal to the leader's ID. For this ID, I cannot omit the table name because ID is included in both leader and the member. I need to specify which one it is coming from. So these are my join conditions, and at the same time I have some additional constraints saying that the member payment of the member, this should be strictly higher than the leader's payment. I'm not including the equals part. If I include the equals, it will also show up for the two same person for the leader, but the question does not ask me to list such things, so it is just saying that paid more than their group leaders. So it means that we are interested in strictly larger than. So if I run it now, sorry, I just clicked on the save option. If I run it now, I will see the student doubles. So for Hal, it shows Diego, and Hal is paid more than Diego. And within this group number within the group number 1, these three people are paid more than their group leaders. And if we were to check it in the student table, Diego, Hal and Daisy in group number 1, Goe is also in group number 1, and for these 4, their leader was actually, if we go into the S group table, for the group number 1, the group leader is the student with number 1, it is Diego, and therefore we see the Diego on the right side always, and these 3 are the members that are paid more than the Diego group leader. So let's create a new query now. So this time it says that double the payment of members of the group who has the lowest sum of payments. So this is an update query. Usually to run update queries, we cannot use this view. Remember, this is the option for create query in SQL view is just for select queries. And just to write it now, I'm going to use here, and then I will go through tools and SQL to run the query. So it is saying double the payment of members of group who has the lowest sum of payments. I actually would like to update something this time in the student table. And remember, we were saying update some table name followed by sets and then the attributes. So I can say payment equal to 0, for example. It will set the payment to 0. In this case, I would like to double the payment. So the new value of the payment is going to depend on the old value of the payment multiplied with 2. And the students that I would like to update is going to be in some specific group. So I will say var in group, and in here I would like to find out the group with the lowest sum of payments. Actually, if we remember with query number 4, in this one we were finding the group with the maximum payments, and this will easily apply to there. So I'm finding the sum of payments for each group, and then instead of finding the max, I can write min. It will find the group with the minimum payment, and it will get me the group numbers of such groups, group numbers of such groups. Yeah. And if I get this subquery parts into here, I will be done. So I'm updating the payments of the students, and for these students I want their group numbers to be among this result set, and in this result set it is returning me the group numbers from the student table where the sum of payments are equal to this value, and this value is actually finding the minimum among the result set that lists the sum of payments per group. If I try to run it in this view, it will say that this is not a select statement, only queries are allowed. So actually to run it, I should go into tools and SQL, and I need to execute this statement. So if I use Ctrl V to paste it here, I need to execute this statement in this part. So if I click on execute, it says that 2 rows updated. Actually the lowest paid group was the one that I just included, remember, with Ali and Ayşe. They had 2 different members. This group was the one with the lowest sum of payments, and therefore their payment is now doubled. But if I execute it multiple times, this time 3 rows updated, it will work for different groups each time I operate, because the payments are updated. So the next one says list name, age and group name of students who are in the groups with most member count. This is actually again a similar one. Let me create a new query. Remember with the query number 4, let me actually just copy this one from here into here. With this query, what we were doing is finding the students that are in a group with the minimum payment. This time we are interested in the ones with the most member count. So in this subquery, instead of getting the sum of payments, so now there is nothing about the payments, we are just interested in the member counts of each group. So in here, instead of getting the sum of payments, I will say, okay, count star. The star is meaning that count them as whole entries. We are not just looking at separate columns. We are calling the records as a whole. And instead of saying pay sum, let's call it student count SC. So in here, instead of finding the minimum of student count, let's find the maximum one. And this is going to be just one value. And in here, instead of saying sum of payments, actually what we want to say is the count should be equal to this value. So for each group, I'm counting the students, finding the maximum, and I'm saying, okay, this group should have the count that is equal to this number. and we need to project the S name, age, and group name. So far S name and age is okay. I can also get the group number. So if I run it now, it shows me the students. I can also get the group number. But if I need to show the group name, then what I need is the table S group. So in here, I get the student table, and I would like to also get the S group table. And this is not enough. I need to specify my joining condition. So after var, so let this whole thing be my second condition combined with and my first condition is going to be the join condition. So I will say students group number, this should be equal to the one that comes from S group. So now, since I have the S group table instead of the group number, I can just project the group name. So the last join that we did is to get the name of the groups, because otherwise the group name is only included in the S group table. So then this is also done. Let's call it query number 7. The next one is saying that list each project number, description, and budget along with the sum of payments of students who are in a group that works for that project. So I need to again select a bunch of things. I need the project number. It's in the project table. I need the project description. It's again in the project table. The budget is also in the same table. But I also need the sum of payments of the students who are in a group that works for that project. So if this was just the first three things, the project table will be enough. I could have just said this information is enough. But I also need the sum of payments of the students that are in a group that works for that project. So students are not working individually for the projects, they are working as groups for projects. And if I were to find which students are working for which project in a group, I need to join a bunch of tables. So for a student, I have the group number, and in the works in relation, I assign group numbers to project numbers. Actually, to find the group, to find the project of an individual student, I need to join the student following these links till the project table. But the group number in here is actually the same. So if I check the links that combine the group number of S group into student and works in, S group is the parent. So actually this link is the same thing. This information is the same information when I'm joining. So usually what we do is joining student with S group with works in, but this time we can skip S group because this group number is the same group number. I can directly join student table with the works in table. So going back into my query, so this is going to be some subquery that I'm writing. And in this subquery, I'm going to include the student table and also the relation called works in. And while joining these two tables, my condition is for the group number that's inside the student table to be equal to the one that's inside the relation works in. So these are both tables actually. What works in is the relationship. So this is my condition, and among these I can, so let me get rid of the one that's above because we would like to test this part. So project number is included in the works in table. If I check it in the works in table, I have the project number, and project number is going to be enough for me. I don't need to join it with the project table to just get the project number. And from here I can also find out the sum of payments per student. So let me just, for now, let's get the S name and project name. If I run this query, I see that for each of these students, for example, Diego is in a group that works for 2 different projects. In group number 1, they are working for project number 1 and 2. Therefore, all members of the group number 1 are matched with project number 1 and 2. In such groups, they are working for some projects. But the thing that we just found out is that for each student, we have the individual projects. To get this information, we joined a bunch of tables. And now we can find the sum of payments of these students among groups. So for this project, there are, for example, for project number 1, there are working, lots of students are working from different groups, and I can sum their payments. So in here, if I were to group according to the project number, because I would like to find out for each project, not for each group, not for each student, but for each project, I would like to find the sum of payments of the students. So the thing that I'm going to project is going to be, in this case, the payments. So if I run this query, now it shows me the sum of payments per project. And remember, this is the result of a function. So to use it, it is good to give a name to this attribute. So now the column's name is project sum. And I can use this as a subquery. So this returns a set of results. And for this set of results, let me call it work groups. So this result set is going to be called work groups when I'm using it as a subquery. And I would like to combine it with this thing that I just did before. So I'm going to select project number, project description, budgets. Plus, I would like to also show the project sum. It is some attributes as well. It's going to be from the project table, so these 3 are coming from the project table. And I would like to include some additional table. And that additional table is going to be actually my result set from this subquery. It's called workgroups. So if this was just some separate table, I can just directly write the name of that table. So if I had a table called workgroups, for example, I can do this, right? There is nothing wrong with that. And then I can say that, okay, I would like to join these 2 tables. And I can say from the project table, let's say I have some project number, and to join these 2 tables in the work groups table as well, let's say I have the project number, which we do. We can make such join operation, but there is no work groups table. Work groups table is a result set actually that we just formed using our subquery. And this is going to be what we want to achieve actually. For each of the projects, we show the project number, description, and budget, plus the sum of payments of the students that are working for this project through a group that works for that project. So this is the query. Let's also save this one, and for today, this was what we wanted to do. So we are finished now, and starting from the next lab, we are going to start using graphical interfaces. So in LibreOffice, actually, we are preparing that thing now currently. We have forms. So we are going to create forms in Design View, for example, and we are going to include some text box, let's say, some button maybe, and for each of these items they have names. For example, text box 1, it's long, let me just call it T1. The user can enter some value here, and whenever I click on the button I can use that value. And To do that, we are going to use macros. So under tools and macros, we have edit macro part. Actually, we are preparing some helper functions to make the life easier. So we are going to just use these functions that we give to you to have the functionality. And this is using Basic, the language Visual Basic. And in Basic, we are not going to see it fully, but let's just call it, we have some subroutines. These are like functions. There are also functions that return values, but subroutines are not returning any values. And let me just call this subroutine like test lab something. This is going to be the end part of the subroutine. And in here, we are going to use the functions that we prepared. So instead of like writing this whole thing, you are just going to use the subroutine to put the result into some item in your form, for example. So we have, for example, get value of function. So in here, I can say that, okay, this, whenever I would like to run this subroutine, it is going to get the value from some form. So each of these windows are called forms, and actually the one that we just created, so let me just save it as some form. So this is the name of my form, and within that form, what I will say is going to be in here. So this is my form name. It's called some form, and the control name is the item that we just created. So the box that user can enter the text, for example, and I can print the value in that form, for example. So I'm going to save this. This is the test lab function, and returning back to the sum form, let's edit it. Whenever I click on this button, I will double click on the button to get the events, and in here I have mouse button pressed. So whenever I'm on this button and press the mouse button, I would like to assign a macro. In this case, I will choose the macro, and that macro is actually included in my database file. So remember the name, it was called test lab. So I will click on OK. Okay, and I will close this once. I will save my form, close my form, and if you double click on the form name, it will be using this form. So if I type something here, and if I click on the button, it will print out, and with this printing out, it will display it in a new dialog, for example. So these will be the things that we will do starting from the next lab, and it is for the project only. Any questions, problems? So this was just some preview of what we are going to do in the next lab. So if you don't have any questions, problems, then that's it for today. See you later.